Hello everyone and welcome to the fourth page of our notes. Today we're going to be talking about the geometric mean theorem. So a geometric mean is going to be representing a proportion, just like we've kind of been talking about. But specifically it's a proportion that has two positive numbers doing something very specific. So what I mean by that is it's going to look like this. You're going to have two numbers like A and B. And if you want to find the geometric mean of A and B, to do that, you're going to set up a proportion where we put A on the top of one fraction and B in the denominator of a different fraction. And then in those two blank spots, we're going to put the variable X. In other words, what that is going to mean to us, let me move this over. I don't know why I put it right there in the middle. What this is going to mean is when I cross multiply x times x and a times b, we end up getting x times x is x squared, and a times b is ab. And when I go and simplify this a little bit, we could square root both sides, and we end up with the square root of ab. So we know that the geometric mean of two numbers is when you multiply them and then take the square root of them. The reason this helps us is we determined that there is a theorem where if you were to take the geometric mean of any right triangle, if you were to draw the altitude of any right triangle, so if you look right here, we've got this right triangle, correct? And they've drawn the altitude straight down here. By the way, you can see this is a right triangle because right here there's a right angle. It's a little bit hard to see, but it's right there. I'll zoom in a little bit so you can see that little box. And they drew an altitude straight down here. And what that did is it created another right triangle on the left side here and another right triangle on the right side here. And so what the geometric mean theorem states is that if an altitude of a right triangle is drawn to its hypotenuse, that's being that long side, then the triangle is split into two smaller right triangles that are going to be similar to each other and to the original triangle. So you can see that I've put three triangles over here. This represents the original one, this big one right here. So we're going to add the letters in as we see them here. So I can see that the length of this side right here corresponds to this here. So it's going to be the A. I can see the length here corresponds to here, so that's going to be my B. And here corresponds to here. So in that one, I'm going to have to do an equation. I'm going to have to add those two together. So we're going to call this side C plus D. And then in this one right here, we've got this medium-sized triangle. That represents this one right here on the left. So I can see that the hypotenuse there is A, so we'll put an A down here. I can see that the short leg is E, so this is going to be my short leg E. And I can see that my long leg is right here, C. So that's going to be C here. And then one last one, we got this little bitty triangle right here that represents this one over here. So again, I got a hypotenuse of B. So I'm going to put my hypotenuse here is B. The little leg right here is D, so that's going to be this little side here. And then one last thing, we've got the medium side is E, so the medium side here is E. So we can see that all three of those triangles get set up. And again, what is super important is that these three triangles are all similar to each other, meaning we're allowed to set up proportions with them. With that said, you're going to notice that there are certain patterns that happen. You could draw all three pictures like this. Some people like to draw all three pictures, and that's useful for them. I think that's a lot of extra work, but it works. It does definitely work. So if you want to take, for example, if you want to take question A here, and you want to draw all three triangles and then solve the problem, you could do that and then set up the proportions, and it will work just fine. What I noticed, though, is that there are certain patterns that we're going to use. So the first one is anytime we're solving when the altitude is given. So notice that here, the altitude is the variable we're looking for, but it's still something that was given to us. Here we have the altitude. Here we have the altitude. Anytime we have the inside piece, we're going to use what we call the heartbeat method. I'll write that right here, heartbeat. And what I mean by that is if you think about like if you're watching like a heartbeat monitor, if someone's hooked up to a heartbeat monitor, they've got that little thing that goes like boop, boop, the sound effects and all, boop, like that thing, right? And that's what your heartbeat monitor would look like. So here's what the heartbeat method looks like. What we're going to do is we're going to take this over this. See how it does like a heartbeat going up? I'm going to switch the color. And then it's going to be the heartbeat going down. This over this. So you can see it's making that heartbeat measurement. Boop, boop. Looks better with the red laser. So this over this is equal to this over this. So if we're looking over here, we're going to go this over this is equal to this over this. Again, you can see how that makes a heartbeat shape. So that's what we are calling that method. So this one is going to be 4 over D. Again, that was me going this over this is equal to, and then the heartbeat went up. So now it needs to come down. So it's this over this. So what that means is this piece right here, see how this is happening twice? It's going up and then coming back down, up and then down, up and then down. So it's going to get repeated twice. So that means we went 4 over D, and now it's going to be D over 9. And you can see that this looks exactly like what we talked about up here, the geometric mean, where these two numbers are the same number. These two are the same. So that represents a geometric mean. So let's go ahead and cross multiply that. So D times D and 4 times 9. D times D is going to give us D squared. 4 times 9 is going to give us 36. And I'm going to have to square root both sides. And that gives us D is equal to 6. All right, so with B, again, you can see the same thing. They gave us something inside, so we're going to need to do the heartbeat method. So you do need to look at it a little bit more sideways, right? This triangle's not sitting flat on the ground. So it's going to be this over this, this over this. So you can see the heartbeat is just sideways now. So it's going to be 5 over 12, then 12 over G. So let's set that up. So we got 5 over 12 is equal to 12 over G. So doing our cross multiplication here, I'm going to multiply the 5 and the G first so we get our variables together. On the left, 12 times 12, that again, we need to have these two are the same. They don't always have to be the variable like over here. Sometimes it's a number, but that's okay. As long as they're the same number, it is correct. So 12 times 12 is 144, which means to solve this one, all we're going to have to do is divide both sides by 5, which isn't really going to give us a nice answer, but it gives us an answer. So G is equal to, what is that, 28.8? And that's it. All right, we got one last one over here. This one, again, we have the 12 inside, so we know we're going to use the heartbeat method. Anytime you're given the altitude inside and it has a measurement on it, you have to use the heartbeat method. So we're going to use heartbeat again. So we're going to do this over this and this over this. But this doesn't represent the variable K. So I think we're going to have to do an extra step at the end. Let's add in a variable here. We'll just call this X for now. Let's just call this X. We're going to solve for X, and then we'll figure out K at the end. So we're going to need to go X over 12, 12 over 16. So let's set that up. So X over 12. And again, we're going to come down 12 over 16. And again, let's just cross multiply that. So 16 times X is 16X. 12 times 12 is 144. Divide both sides by 16. And we're going to get X equals 9 here. Oh, wait. Nope. We're not going to do that yet. Again, with this one, we know that now that this X equals 9, but that's not what the question said. They wanted us to find the missing variable K. Well, K is the measurement of this whole thing, the 9 and the 16. So we just need to add those two together now to get our final answer. So 9 plus 16, and that equals 25. So we know that K is equal to 25 in this case. All right, so that takes care of the heartbeat method. The other method is called the boomerang method. So let's talk about what that looks like. Anytime they're using the legs of the right triangle. So if you look in this case, see how they gave us this F outside here, or this 25 over here? That's when we have to use the boomerang. Notice they didn't give us anything in the altitude. There's nothing on the inside, so you can't use the heartbeat method because you don't have the inside where the heartbeat is. So the boomerang method, all a boomerang, if you don't know what a boomerang is, kind of like looks like this, and it's an old Aboriginal weapon that they could throw, and the boomerang goes and it hits something and then it turns around and comes back so that they don't have to go retrieve it. So that's what we are using here. The boomerang is going to be something that we throw and it goes and it turns around and it comes back. So there's two ways you could see this. If you start here, that means you are looking for A, or that A is given to you. So whenever you're given a leg, you have to start at the opposite corner. And you're going to throw the boomerang all the way down, and then it's going to go around the corner. And that's going to be your first proportion. So in this case, it would be D plus C over A, and it's going to turn around and come back, and A is going to repeat, and it's going to come down this way, but it's not going to make it all the way back. It's going to stop when it gets to the altitude. So it'll only be A over C. So let me write that down. So the first version of this proportion, looking at what we just did, and actually let's just draw an arrow. We're going to put a point here. We're going to go this way, around, and then back. So it's going to be D plus C over A is equal to A over C. Again, this is for situations where A is given to us. And so if we did it a little bit differently, what if they gave us B? Well, the only difference is we're going to start this corner instead. And so it's still going to be C plus D, but now it's over B. And then it turns around and comes back, and it's B over, and it's going to stop here. So it's B over D. So it's going to be a little bit different, but it's essentially still the same thing. This way, around the corner, come back to here, and it stops. Again, we started over here. So this one was, we can call it C plus D over B is equal to B over D. In other words, kind of look at this last one. See how this is A over C on the top one? A over C come from here. See how this one's B over D come from here. So it should always end with two letters from the same triangle. So taking a look at this one. They gave us this leg over here. So I know that I have to start at the opposite corner over here. So when I throw the boomerang, it's going to go all the way down the hypotenuse. So we need to know how long the entire length of the hypotenuse is. Let's just do that right off the bat. We know the whole hypotenuse is going to be 9 plus 4, which is 13. So the proportion is going to start here. It's going to go all the way down the 13, around to the F, turn around and come past F again. But when it comes back, it's going to stop at this altitude. So we're only going to use the 4. So let's set that up. It's going to be 13 over F. That's us throwing the boomerang originally. So 13 over F throws the boomerang. And then the boomerang gets over here and it comes back. So it's going to be F over 4. It has to stop. It can't keep going. It loses some of its momentum and it stops part way. So it's going to be F over 4. Again, just like with the last time, these two should be the same letter. It's always going to be this one duplicated. So whatever that is right there on the leg, we're going to duplicate it. So F times F is F squared. 13 times 4 is going to be 52. And we're going to have to square root that. And we end up getting F equals, I'm gonna simplify this by rationalizing. So I know that this is the same thing as 4 multiplied by 13. And the square root of 4 is 2. So I'm going to pull a 2 out and leave the 13 inside, and we'll call it 2 squared to 13. You might also be able to give the decimal answer. In fact, it doesn't say what we should give the answer as, but you could just put square root of 52 in your calculator, and you'd get approximately like 7 point something. I don't know what the answer is, but it'd be 7 point something. Actually, hold on. I got a calculator right here. I didn't know I had one near me. Square root I actually don't know how to use this calculator. Square root, there we go, 52. So it would be 7.21. So either of those answers are technically correct, but make sure you do know how to do both of them. All right, taking a look at B. In this case, we got this 25 over here, so we know that we're starting at this opposite corner. Remember, you always got to start the opposite corner of the leg. So we're going to throw the boomerang all the way down the hypotenuse. In this case, we don't really know how long the hypotenuse is. In this case, the hypotenuse all the way down, we see that there's an n and a 24. So we know that the entire hypotenuse is those two things added together. We don't really know what that means, though. N plus 24 is all we got. The whole hypotenuse is n plus 24. And then it goes around the corner for 25. That's going to be our first proportion. N plus 24 over 25. And again, once we've thrown our boomerang and it's all the way up here at this right angle, it's going to turn around and come back. So it's going to be 25, and it comes around the corner, and it's got to stop at the altitude. So it's going to be 25 over 24. Again, double check. Are these numbers the same? Yes. So we did it right. So let's go ahead and figure out what we're going to get when we do this. So 24 cross multiplied up to the n plus 24. So we got 24 outside the parentheses. Let's put, whoa, that was weird. Let's put parentheses right here around this. Actually, let me get rid of that giant line through there. Let's put parentheses around this. We're going to do 24 times n plus 24. And then here we got 25 times 25, and that's going to give us 625. And we can go ahead and distribute here 24 times 24 times n plus, and we got 24 times 24. Let me type that in a calculator. 576 equals 625. And so we know that we're going to have to subtract this 576 here. Cancels. Zoom in a little bit closer here. And I can bring down the 24n. And what do we got left there? That's going to be 25, 24. That's 49. Okay, and then we're going to have to take that and divide it on both sides. So divide by 24, divide by 24. This cancels, and we end up getting n equals... that's going to be a weird number. Let's see, 24. 2.04. And that will be our solution. And then we could put that in there. We could actually find the length of that hypotenuse if we wanted to, but it didn't necessarily ask us to do that. So hopefully that helps you out. Use the heartbeat method if it's inside. Use the boomerang method if it's outside, and you are all set. Let us know if you have any questions. Have a great